Hi, this is Butch Clark with XIO Technologies. Welcome to the VVol Essentials Overview Sessions. We're going to do a VVol flyover, taking a look first at what VVols are. In the second overview session, we'll see what's required and what the major components are. In the final overview session, we'll see how VVols can benefit you. So first, what are VVols? As I mentioned in the introduction session, VVols, or virtual volumes, is the VMware implementation of software-defined storage, or SDS. Just as the compute function and more recently the network functions have been virtualized, SDS virtualizes the storage layer. It lets you abstract up the storage, sometimes from multiple storage vendors, so that you just manage the storage, and you don't care how things get actually done on the physical storage level. So, for example, let's say we need a 6 terabyte volume created. We use an SDS management interface to define what we want and press the big green Go button. The software underneath will figure out the best place for the new storage volume to be created from all the available storage resources and return to us the volume ready to use. Now, in the case of VMware and VVols, this is done all within vCenter. I, as a vAdmin, will define storage profiles, essentially templates, for what I want my various VVols to look like. When I create a VVol, I can assign it a storage profile. This is the construct that houses the various storage attributes required. vSphere will go off and match the attributes requested to storage capabilities it has available to it. The volume will then be created on the appropriate physical storage, but I don't have to do any of the figuring out. This is very similar to when I create a virtual machine. I specify I want X gig of RAM and Y processors and so on. The vSphere then goes and returns to me the new virtual machine on the most appropriate host server available. Now you might be asking yourself if this really is all that different from the past. So before we move on, let's take a look at how this differs from the previous model, where virtual machine disks are created in a data store. Before VVols, a storage admin would create a volume on physical storage. This volume was then presented to the vSphere hosts that needed to access it. Once done, the vAdmin would create a data store housed in the volume. This data store got its storage attributes or characteristics from the underlying volume in which it was created. Now, when the vAdmin creates a virtual machine, it's assigned to a data store. Any disks needed for the virtual machine will be created within the data store. Each disk is made up of a bunch of little pieces that, when fit together, give us the disk. As more virtual machines are created, all of their disks, made up of little pieces, are also created within this data store. So far, so good. Now, if we want to change the characteristics of the data store, we can change the underlying storage volume. Once completed, all the VMs housed in the data store will reflect the new characteristics. But what happens if I want to just make a change to only one virtual machine? Let's say my NoSQL database server needs beefier storage resources, let's say. I have a couple of options, including changing the entire data store. As you might suspect, this affects all the virtual machines living in that data store. I could also migrate the VM out of the data store into a better suited one. In this case, the operation will be required to go through vSphere, meaning that the data movement is initiated and managed by the hypervisor. Neither case is ideal. In the simplest case, VVols look like this. The storage admin presents a special placeholder volume to the hosts. The vAdmin creates storage profiles that define the characteristics of different types of VVols needed. When the new virtual machine is created with a storage policy or profile, it has a set of disks, but this time they're VVols. Each of these disks is essentially an individual volume on the storage. There is no big barrel that defines the overall storage characteristics. Now if I want to change my NoSQL database server to faster storage, I simply change the storage profile for that VM. vCenter will send the request to the storage layer, and the storage itself takes care of ensuring that the proper services are available. This gives you a very fine-grained control over your storage resources, while at the same time making it easier to manage. It really is a good combination. In the next session, we'll look at VVol requirements and components. See you then.